First off, thanks to everyone for being today. There's a lot of familiar faces and some unfamiliar faces, so it's nice to see all of you. Thanks especially to everyone who was involved somehow with my PhD process. Especially just a couple people I'd like to thank off the top. Mark, obviously been a tremendous supervisor, so thank you very much for everything you've done. Gary and Glen, you've been a great committee. You've gone sort of above and beyond what was needed, so thank you. JP merci beaucoup pour ton aide. À part de Marc et personne qui m'a aidé plus que toi. Merci. Tu m'as forcé de parler en français. Also, Pascal and Susan, thank you very much. I appreciate your comments. I'm really looking forward to talking with you. And of course, my family. My parents come a long way from New Brunswick. They're very anxious to back it. And my wife as well, so they've all been very supportive. Dawn's actually only known me as a student, so that's kind of interesting. So, all right, so without further ado, so today I'm going to be talking about the health impact of sedentary behavior in children and youth. And so just to define a couple of key terms off the start. So when we're talking about sedentary behavior, we're talking about any activity that's characterized by two key things: a very low energy expenditure and a sitting or reclining posture. So common sedentary behaviors are things like watching TV, playing computer games, driving a car. Those are all very, very common sedentary behaviors. And so anytime basically that you're sitting down, you're being sedentary. So my committee and most of you are technically being sedentary right now. Myself and the people at the back are not being sedentary by its definition. The other thing I'm going to be talking about a lot is cardiometabolic risk. And so cardiometabolic risk, it's not a specific diagnosis, it's not a specific risk factor. It just refers to someone's global risk for type 2 diabetes and cardiovascular disease. So it involves a variety of risk factors. So here are a couple. It involves both traditional and non-traditional risk factors. And so broadly speaking, just someone who has higher cardiometabolic risk is more likely to get one of those diseases than someone with lower risk. So you want to have low cardiometabolic risk. And so very broadly speaking, in kids, we know that kids who engage in a lot of sedentary behavior are less healthy than kids who engage in less sedentary behavior. So that's the general trend. But in my thesis, I'm going to look at 4 specific questions related to the relationship between sedentary behavior and health in kids. So for study 1, we looked at associations of sedentary behavior, breaks in sedentary time, and sedentary bouts with markers of cardiometabolic risk in kids with a family history of obesity. And so this study, we used the quality cohort, which is a cohort from Quebec, which has it has more than 522 kids, but there were 522 with usable data for us. So they're all between the ages of 8 and 11, and they all have at least one parent with obesity. So our exposure variables in this were total sedentary time, breaks in sedentary time, and sedentary bout length, and those were all objectively measured using accelerometry for 1 week. And then we also assessed self-reported TV viewing and computer and video game use in these kids. And then our outcomes were a range of cardiometabolic risk factors, so waist circumference, BMI, circulating factors. And so we looked at each of these risk factors individually, and then we also created a clustered risk score, which combines all of these individual factors into one global measure of a person's overall cardiometabolic risk. So these are the results for that first study. And so what we found is that after adjustment for confounders, both breaks in sedentary time and short bouts of sedentary time were associated with reduced cardiometabolic risk and body mass index in this group of kids. We also found that screen time was also important, but it sort of differed by sex. So computer and video game use was associated with increased cardiometabolic risk in boys, whereas TV viewing was associated with increased risk in girls. And so just to sort of summarize those results in a different way, let's assume we had two kids who were essentially identical, and they had the same amount of physical activity and the same amount of daily sedentary time. The only difference is that one gets frequent breaks in their sedentary time and one has infrequent breaks. And so these findings suggest that the kid with the more frequent breaks is actually reduced cardiometabolic risk than the kid with infrequent breaks in their sedentary time. And now these findings also suggest, assume again we have 2 girls that are essentially equivalent in terms of total activity and total sedentary time. They suggest that the one with less screen time is actually going to have lower cardiometabolic risk than the one with more screen time. And again, for girls, it seemed to be that TV was really the important one. For boys, it was computer and video game use. So now looking at study 2, just to change gears a little bit. In this study, we looked at movement variability, which is a new metric that we actually created. And we looked at its association with cardiometabolic risk in the NHANES sample. So this sample is a representative sample of American children and youth, age 12 to 17. We had quite a big group of kids, over 1,400 kids. And so what we looked at was movement variability, which we defined as minute-to-minute changes in accelerometer counts per minute. And then we had very similar outcomes to study 1, so we looked at a variety of individual cardiometabolic risk factors, and then we created a global clustered risk score as well. So these are the main results for that study. So just to orient you here, we've got clustered risk score on the y-axis, and so once again, a high risk score is bad. You want to have a lower value for this. And we broke our participants up into 3 groups, those with low levels of movement variability, those with a moderate amount of movement variability, and those with a high level of movement variability. So this is clustered risk in that group of kids with the lowest movement variability. So here's the clustered risk for the girls in that medium group of medium movement variability. Here's the clustered risk for the boys in that group. So you can see in the boys in this group, there's significantly less or lower cluster risk score than the ones in the lowest category of movement variability. And then finally, in the highest category of movement variability, there was significantly less risk for both boys and girls. So once again, just to sort of use the same sort of slide, once again, these results suggest that if we have two girls that are essentially the same in terms of total physical activity and sedentary time, these results suggest that the one that has more movement variability is going to have lower cardiometabolic risk than the one who has less movement variability. So now moving on to studies 3 and 4. So these were an intervention study, and so you can see we've got a whole bunch of acknowledgements here. So not only the participants, but a whole lot of people that helped out. So thank you. I know a lot of you are here that helped out with the study, and it took a lot of work to do these next 2 studies, so thank you for everyone who contributed. So this first study we looked at the metabolic impact of prolonged sitting. So for our methodology, we had 19 participants, 11 boys and 8 girls, all between the ages of 10 and 14, and they experienced 3 conditions in random order. So the first condition was simply sitting for 8 straight hours. They came into the lab, they sat down, they didn't get up till the end of the day. And so this is the accelerometer output for that day, and you can see there's one little spike there at the beginning, and otherwise, these kids did not move at all for the whole day. We actually borrowed a wheelchair from my father-in-law, so if they had to go pee, we could wheel them to the washroom, wheel them back. So these kids were completely sedentary the entire day. The second condition was sitting with breaks, and in this condition, they sat the full day, same as before, but every 20 minutes they had a 2-minute walk break on a treadmill to light intensity. So you can see here on the accelerometer output, each one of these little spikes is a little light walk for 2 minutes. And then finally, the third condition was sitting with both breaks and structured physical activity. So it was same as the last one, but in addition to having those breaks every 20 minutes, which you can see here, they also had a 20-minute bout of moderate physical activity in the morning and a 20-minute bout in the afternoon. So everything else was the same, just in this one they had both breaks and structured physical activity. And like I said, these were all done in random order, so they did them in different order for each participant. So now we gave each participant individualized meals, both breakfast and lunch, and they were identical for the 3 sessions for each kid. So this is one of our lunches here. We did blood draws at 8 a.m. and the subsequent blood draws every 90 minutes till 3:30. And our outcomes were insulin, glucose, and lipid areas under the curve. So glucose and lipids were actually done at the CHIO core lab. Insulin, I actually did the test myself under the direction of Heather Wright, who's one of Glen's former postdocs. So here I'm doing some insulin tests there. So these are our results for insulin, which was our primary outcome. So these are the insulin values on the day where the kids were sitting all day without interruption. Here are the insulin values on the day where they sat, but they had those breaks every 20 minutes. And here are the insulin values on the day with both breaks and the structured physical activities. And so I know it kind of looks like there's a trend there to be different across the conditions, but when you add in the error bars, you can see there was no significant difference across the conditions, whether you looked at a specific time point or total area under the curve. Now glucose values is much the same story. There was a little spike in blood glucose levels at the second blood draw right after the exercise session in the exercise condition, but that was the only difference across conditions. There were no differences at other time points. There were no differences in the overall area under the curve. And I'm not going to show the lipid and cholesterol changes, but it was much the same story. No significant differences across conditions. So our conclusion based on these data is that in comparison to a day with interruptions or structured physical activity, a day of uninterrupted sitting does not appear to acutely influence circulating markers of metabolic risk in healthy children and youth. And so now finally looking at study 4, so this used that same intervention study, but instead of looking at the metabolic outcomes, we looked at behavioral outcomes. So we looked at food intake and physical activity following their time in the lab. So just once again to remind you of the intervention, so the same 3 conditions, the same kids. But what I didn't mention before is that after the final blood draw, we gave a buffet meal. So here's Mike Borghese and Nico Sakis preparing the buffet meal for our kids. So we weighed the amount of food they ate at following each of the 3 conditions. We also measured physical activity and sedentary time after they left the lab for 24 hours using accelerometers. So they wore this home, and they wore it for 24 hours afterwards, and then we were able to see how active and how sedentary they were once they left the lab. So these are the results for energy expenditure during their time in the lab. So as we designed it, there was a significant difference across the conditions. So as you can see, in the lab, they had the lowest energy expenditure when they were sitting all day, which makes perfect sense. Slightly higher on the day where they had breaks in sedentary time, and the highest on the day where they had both breaks and structured physical activity. So exactly what we expected. When we look at contrast at the energy intake in the three conditions, there were no significant differences. So as far as we can tell, kids didn't go home after sitting all day and eat more or eat less. On the buffet meal, they didn't eat any more or less. It was the same. It was like that for all measures of hunger and all measures related to the buffet. There were no differences across conditions. So now looking at the physical activity levels, so this is after they left the lab for that 24-hour period. And so whether we looked at sedentary time, at light physical activity, at moderate physical activity, or vigorous physical activity, as you can see, there was absolutely no difference across conditions. So sort of counterintuitively, we expected, if kids are sitting for 8 straight hours, they're going to go home, be jumping off the walls, be really excited. We didn't see any evidence of that whatsoever. They were no less sedentary and no more active after a day of sitting than they were after a day that included a decent amount of physical activity. And so our conclusion is that children and youth don't appear to compensate for a day of prolonged sitting by either reducing food intake or increasing physical activity. And so obviously if this is done over time, that could obviously promote weight gain if you're not compensating for that prolonged sitting. So now just a very brief discussion of the thesis as a whole. So just some limitations of the thesis. We focused only on North American children and predominantly on Canadian children. So the quality sample is only white children, and our sample in our intervention was largely white as well. So we can't necessarily generalize these results to kids from other areas or other backgrounds. Studies 1 and 2 are cross-sectional, so obviously we can't make conclusions related to causality based on those results. Also, studies 3 and 4 may not generalize to more chronic exposure to sedentary behavior, so we only exposed kids to 1 day of prolonged sitting. If we had exposed them to 8 hours a day for a week, we might have seen something different. And finally, the results of studies 3 and 4 may not generalize to other populations of kids. So our kids were more active than the average Canadian child, they were less sedentary, so they may not generalize to older or younger kids, to those who are less active, or to those who are overweight or obese or have elevated levels of metabolic risk at baseline. And however, we do have some good strengths for this thesis. The big one is that we use a variety of methodological approaches. So we didn't use just cross-sectional analyses. We didn't use just the intervention. We used the 2 types that really strengthened the thesis and allowed us to look at sedentary behavior much more broadly than we could have if we had only used one methodology. We also had a rigorously controlled randomized crossover study. So anyone who helped out with that knows that it was a complicated and time-consuming study to run, but it was also very rigorously controlled. And finally, we directly measured our core outcomes in every study using accelerometry. So physical activity and sedentary time in studies 1, 3, and 4, and movement variability in studies 2. And so finally, just the take-home message from my thesis, I think, is that in addition to physical activity, which we already know is important, I think that my thesis sort of suggests that there are 3 characteristics that they're associated with optimal health in kids. So one is that they limit their time engaging in screen-based sedentary behaviors. One is that they frequently interrupt their sedentary time. And the third is that they have high levels of movement variability. So that concludes my presentation. I'd just like to briefly thank everyone from Halo. It's been a great place to do a PhD, and I really enjoy our road hockey especially. And obviously thank you to all the funding agencies that supported me or one of our projects. So I'm happy to take your questions now.
Thank you. We start with the first round of questions, and Dr. Sisson, the external examiner, is going to start first. Dr. Sisson?
Yes, can you all hear me?
We can hear you, we can't see you yet.
Okay. You should turn up.
Close the show. There we go.
Yeah.
Okay.
You have a screen?
I don't know how to make it bigger.
Okay.
They're kicking in, whoever runs this.
Oh,
Okay, let's see me now. Okay, Travis, first of all, very nice job. You clearly worked very hard over a number of years, so thank you for that. My first question is on movement variability, and I appreciate that you said that y'all kind of invented this concept, because in reading your dissertation, I was a bit confused. And so I guess my question is just higher movement variability, that essentially, it seems to me, starts and stops. Breaks in sitting or breaks in activity, and would it just be that people with more overall dyslexia, overall MBPA, have more movement variability? You're out for a run, or if you're playing soccer, there's lots of starts and stops in that. Is that in and of itself more helpful than the run or the 90 minutes of soccer or whatever?
So that's a good question, and I think the immediate answer is we're not entirely sure. The thesis or study 2, it didn't compare the impact of prolonged bouts of physical activity versus sporadic bouts. So we weren't looking at that. We were looking at, independent of total physical activity time, whether or not people who had more variability in their movement, whether or not that was beneficial. And so there are 2 reasons why it might be. It could be that there's something beneficial just simply transitioning from light to moderate, moderate to vigorous, sedentary to light. There could be something beneficial about that variability itself, or like you said, it could be representative of a healthy movement pattern. Because to get high levels of variability, you need to have frequent breaks in sedentary time. You need to have a high level of moderate and vigorous physical activity. You need to have a lot of vigorous. So it might just be a metric that sort of captures these beneficial qualities of an overall healthy movement pattern. But it was interesting that it was independent of total sedentary time and MBPA. So I don't think it's just that people are more active are getting more movement variability. We actually graphed the 2, and there's still quite a bit of variability. Actually, I'd pull it up, and I'm not sure I don't think you'd actually be able to see it probably. But there is, at a given level of MBPA, there's still a very wide range of movement variability. So they're correlated, but it's not a perfect relationship.
So the movement variability is really transitions, regardless of. Okay, so sedentary to light, that's movement transition, or moderate to vigorous. That's still a movement transition in and of itself.
Exactly. And so.
Or am I misunderstanding?
No, that's exactly. So we're looking at the changes in accelerometer counts per minute. So as far as movement variability is concerned, going from 0 counts per minute to 1,000 counts per minute, so from sedentary to light, is equivalent as going from 1,000 to 2,000, so light to moderate. So it's just that change from one to the next, as at least the way that we've created this variable that we use in that study.
So being a busybody is a good thing.
It seems that way, at least in this sample, yes.
Okay. Do I still have time for another question, or is my time up and wait till the second
Please
half?
go ahead, we still have time. Please go ahead.
Okay, so moving on to study 3, I believe that PA day where they had that exercise bout, I think it was 60%. There wasn't a difference, which is a little bit contrary to a variety of the literature, and you know that I have been working on very similar sort of feeding studies, and so this is really of interest to me. I can't believe it's changing, even with the day that his did the exercise. I mean, I can sort of get with the light, you had fit kids, and the light dose is light, and my study showed the same, it wasn't a huge effect. Do you have a comment on the MBPA on why you didn't have a difference in your cardiometabolic?
No, I think, because I've been looking through the literature, because I was surprised as well, and even independent of the sedentary behavior literature, you'd expect that a bout of moderate physical activity should improve, your insulin sensitivity, glucose tolerance, and those sorts of things. So, but it seems like the studies I've been able to find in kids, especially healthy kids, all seem to have used a larger volume or intensity of physical activity, or both. So we had the 2 bouts of 20 minutes, and so I think the shortest I found in the literature was like 40, 45. And so it may be that if we'd done the bout at once, that could have made a difference. The other thing, and you got at this I think in some of your comments, your written comments, is that it may be if we use a more challenging meal that was higher in sugar or higher in fat, that may have made a difference. Or if we had taken blood draws more frequently, although we were quite limited in the amount of blood we could take throughout the day. So I think those are all plausible reasons that could explain it, but I think the size of the exercise stimulus might be a big one.
I'm trying to wrap my head around that too, and working on my own project and dosing issues, and in most of the other literature, they 25% VO2 moderate, and I'm like, I'm not quite sure that's moderate, that's pretty hard, but
Yeah.
that's like, I think maybe why they're seeing an effect when they call it moderate exercise is because that's quite intense for moderate. Can you tell me, in your paper, and I actually pulled out your metabolism paper, what were the grams of fat? Isn't it the macronutrients, balance, the percent carbs, and that sort of thing? Could you tell me what the grams of fat were? Do you know that information or not so much?
Yeah, no, I got that. I actually, so I'm just going to go here because I got it on a slide, just I knew I might forget it. So,
Okay.
So the macronutrients, yeah, so we had, at breakfast it was 23 grams of fat, and at lunch it was 31. So I'm not sure if you can see this, the table there. So that's the breakdown for the macronutrients, both breakfast and lunch.
And 1 grams at lunch. Yeah. So I would say, looking at literature, if you are going to continue on in this area, to definitely use a much higher fat load. Something in the neighborhood of 50 or 60 grams. I couldn't see your slide, but I wrote down what you said. 50 or 60 grams of a fat load. My final question, I think probably before I run out of time, as you mentioned that the meals were based on the children's individual energy intake, expected need, energy, I'm not sure I'm saying that correctly, but based on their individual energy needs.
Yes.
And so, could the kids just eat what they wanted to eat?
I'm sorry, can you just repeat that last bit?
And the lunch could the kids just eat what they wanted from the meals you provided? You list in the paper the foods that you served. So do the kids have to eat it all for their individual meals so that they were getting the appropriate percentage of their energy they met? Or what kind of control that for ensuring they ate what they were supposed to eat or didn't? What did you have?
Sure. So what we did was we based breakfast was 25% of their estimated energy needs based on their test of their resting energy expenditure and their baseline physical activity levels. And then lunch was 40%. And so we use those foods and we use them in different amounts. That's why the percent intake of carbs and fat and protein differed a little bit from kid to kid, because we wanted to make sure they were getting the energy needs, and then we kept them all in the same range for macronutrients, but it was a little different for each kid. And then we just simply required that they eat all the food that was provided. So we asked ahead of the study if there were any specific intolerances, anything that the parents knew they would not eat. So we had a vegetarian participant, so instead of getting chicken wings or chicken nuggets, she got veggie patties. We had a girl with celiac disease, so she got gluten-free stuff. And so they got identical foods at each time, and if there was something left on the plate, we'd go in and remind them they had to eat it. And they were generally pretty good about it. And so
yeah,
that
did they
Sorry?
eat the meal? Uh-oh. I'm sorry, I think my computer wasn't touching my mouse. Did they have a time limit on eating the meal?
So it was within a half hour that they had, so it wasn't
Okay.
too rushed, but it wasn't dragging out forever.
Yeah, I have definitely experienced the not wanting to eat. So when we do this again, we're going to have at our consenting visit a sample of the food because they just are sometimes particular. And surprisingly, here in Oklahoma even, which is sort of like the south and the west of the United States, we had some vegetarian requests as well. I was super shocked. But well done. Thank you.
Thanks.
Thank you, Dr. Sisson. Dr. Imbeault.
Yes, thank you. I'll just start with rating my.
There, yeah, you go.
Your two actually
Yeah.
seems to be good. Travis, as my predecessor mentioned, like you delivered, and since we're talking about kids, you delivered a very nice baby. I'm referring to your thesis.
Yes.
Yeah, Don doesn't know. Yeah, I mean, I can tell that you basically seized every day of your PhD adventure, and you know, as I said to your parents, to reconfort them, like I think today's going to be just a nice scientific fiesta. So it's just, you know, we're going to push you up to the limit, because the thesis per se is to me like reflecting like a very nice journey, as I said. So you already mentioned like my questions will be basically designed as an exercise session, meaning that, you know, it's going to be generally light at the beginning and maybe get to the high intensity at the end if I feel to, but you know, we'll see. So generally speaking, I would like to, you know, you already touched base like this topic when at the beginning of your presentation, you talked about the cardiometabolic risk.
Yeah.
And I guess for the benefit of the audience here, I would like you to give us some more insight related to this new picture or new term in the medical or physiological field. So you already mentioned what does this entail, but can we provide numbers, and how do we qualify this, simply said, like, to people out there?
Sure. And I think Jess actually, somebody is sort of trying to sneak in, I think.
We're trying to.
Hi. Yeah, so it sort of evolved from, I mean, first we had type 2 diabetes and cardiovascular disease. And then, I'm not sure, before I started my master's, maybe 10, 15 years ago, sort of the metabolic syndrome and insulin resistance syndrome, and these things sort of gained prominence as the common soil for these important chronic diseases. And so there started being more interest in people who didn't quite have type 2 diabetes or cardiovascular disease, but had a clustering of risk factors. So they were insulin resistant, they had abdominal obesity, they might have had, you know, hypertriglyceridemic waste. They had this clustering of things that we knew were bad and seemed to be especially bad to have in combination. And so now we have, you know, metabolic syndrome criteria, and recently it seems, or in the past 10 years or so, we started to realize that those are important, but there's also other non-traditional risk factors that are also important. So things like inflammation and vascular function, and it seems like there's always, you know, new cytokines and adipokines being added. And so metabolic syndrome is sort of the one with the numbers and this precise definition, whereas cardiometabolic risk is sort of the more global, fuzzy definition of the things we know that are probably contributing to type 2 diabetes and cardiovascular disease, but it's not a specific thing. And then in kids, the reason why I went with that rather than something like the metabolic syndrome is that, so metabolic syndrome is nice that it's a specific definition, but there is no real metabolic syndrome definition in kids. You can sort of tweak the adult definition, and it's also like a dichotomous, you either have it or you don't. And so statistically you lose a lot of power there. So in studies in kids in the past 4 or 5 years, a lot of studies have moved to this clustered score, and it differs exactly how people create this clustered score, just taking, you know, established risk factors for diabetes and cardiovascular disease and combine them into a common metric.
So you, at the end, you get a score as
you do.
The metabolic syndrome is kind of quantified to some extent.
You do. So, but instead of being a yes/no, it's a range.
Okay.
And so the way we did it was by creating a Z score for each individual risk factor,
Right.
and then just adding them up. So someone who has, you know, is 1 standard deviation above the mean for waist circumference and BMI and fasting insulin and all these things, then they have a very high cluster risk score, which makes sense because you expect them to be at higher risk versus someone who's standard deviation below the mean would have a lower risk. So it's not a perfect measure, but it's one that's kind of, it's convenient and becoming more common in kids because it sort of captures what we're trying to get at.
And of course, you know, I don't have the data fresh in my mind, but could you remind us like the range of this cardiometabolic scores that you got in your 2 first studies?
So, and I should mention it's also sample specific, so you can't necessarily compare one study to the next. So I don't remember the range. I know the mean for both was very close to 0, which is what you'd expect when you're adding together a bunch of Z scores. And I think your range, I'm going to say from about -3 to +3. Like if you remember in the movement variability study, the kid with the lowest variability had a mean of like -1 or -1.2 in the lowest group. Then it was about +1 or +1.2 for the mean of that highest group. So the total range was a bit above that, but it's sort of, you know, between 1.5 below and above is probably the majority of the kids, I would think.
So cardiovascular or cardiometabolic risk was one key component of the thesis, and the other one is the one that you just mentioned, the movement variability.
Yeah.
And for the physiologist that I am, I would like you to give us some, again, like people will think that I'm a quantitative maniac this morning, but like, could you give us like a number of what this movement variability
Variability.
Exactly. How is it translated in terms of kilocal per day, for example? So if I just did that, like to me it's less than 1 kilocalorie for sure. So are we able to basically quantify like the amount of kilocalorie that this is reflecting in terms of the variability of movement?
That's a good question. And my initial, so we didn't try to do that. My initial answer would be probably not, because as I was saying to Susan, going from sitting to standing is the equivalent of going from standing to running as far as this is concerned. And so it's not around energy expenditure, it's more about those transitions, and it seems like the sedentary field as a whole, it seems as though energy expenditure plays a lot smaller role in the health impact of sedentary behavior than you'd probably initially expect. And so it's, especially in adults, a lot of the mechanistic studies suggest that it's not that you're burning through your calories, it's that your muscles are becoming insulin resistant, it's that your LPL activity is going down. So it's more of the metabolic changes in the muscle as opposed to the actual caloric benefit. Because even in some of the studies in adults, it's shown big differences in breaking up your sedentary time. The actual energy expenditure has been very low. And so for movement variability, I'm assuming if it turns out in other studies that it is important, I think it would be less about energy expenditure and more about something metabolic in the muscle being, that variability in the stimulant.
But you agree with me that this change in metabolic status is translated by energy consumption to some extent. So to move from like a cell that is static or not in movement, like the fact that I'm standing up, involve like a certain amount of energy requirement.
It's certainly one of them, and so I think, and that's some of the interesting stuff with the mechanisms for sedentary behavior, that they're often parallel pathways with what you see for exercise physiology, but and similar endpoints, but they operate in different muscles or via different actual processes.
Okay.
And so I think for movement variability, because it's kind of getting at both sedentary time and physical activity, I think the energy expenditure would certainly be a part of it. But I again, if it turns out in other studies that it's important, I don't think it would explain all the benefit. I think it would be one big part.
Because we see the reason why I'm asking that is, I've been working with adults, mainly, in fact, all the time, and kids is not a spirit that I'm aware of, but, is it the same kind of breakout in terms of the energy expenditure or the thermogenesis related to lactic adults versus kids, like on a total energy expenditure, they, for example, like the contribution of physical activity is about 15 to 30% in adults. I was just wondering if this break in sedentarity was bringing up this percentage to a significant level compared to the kids that is basically not having those break in sedentarity.
Right. I don't know. I mean, it's plausible, but I don't know, because again, the breaks are simple as just going from sitting to standing, so that the energy expenditure associated with that is so low. And again, it's in our study the breaks were independent of physical activity, and same with the movement variability. So I think it's probably impacting energy expenditure a bit, but I don't think it's the key component. And even they've done studies in kids to look at using a standing desk versus a sitting desk, and you burn more when standing, but it's not much more. Like it's like way less than a calorie meal. Like it's very, very small. And even in our study, when you looked at the estimated energy expenditure based on accelerometry and our brakes condition, it was still only 200 kilojoules, I think, was the difference, 200 or 300. So I mean that's not many calories from spending. They had I think 36 or 38 minutes walking to light intensity, so they weren't burning a whole lot more at that speed.
I'm basically asking those questions to prepare you for my next round of questions that will be in 50 minutes.
All right.
Gary,
Okay, thank you,
You still
Dr.
have some
Goldfield,
question
I
here?
think. Dr. Goldfield?
Yeah, thanks. Travis, I always enjoyed going to your PhD thesis and to be part of some of the studies. It's a very nice piece of science, a nice mix of cross-sectional examinations using large data sets with kids at risk, national representative, American youth, and topping up a very nice, tight, randomized crossover design that can effects of manipulating sensory behavior on risk and food intake and food activity, which is quite novel for a study of its kind in children. So, congratulations on all that. I'm also, as you probably know, I like to start kind of small and then go broader as I go along. So one thing you mentioned in your presentation and in your thesis in study one was some gender differences around screens on cutting my blockers, but I don't believe you discussed them in the thesis or the paper. So you found that boys, there was a greater association between computer time and cutting my blockers in boys only, and an association with TV and risk in girls only. I'm just curious to any thoughts on why that sex difference is.
So, I mean, I kind of speculate, and obviously, you know, we've had this in other studies, right? In the Hardy sample too, it was very, very similar. And my guess is that when you look at the amount of time spent, self-reported video game time and computer use was a lot higher in boys than it was in girls. And so I think that's probably a big part, is that boys are just spending more time playing video games. So I think that's the simplest answer there. I don't think that they're necessarily, I don't know there's necessarily I think there's probably not a physiological reason why boys would be more impacted by video games and girls would be more impacted by TV. I think it's just where they're spending their time more is the simplest answer. I think something that would be interesting to do would be sort of like JP's video game study, looking at video games on energy intake. JP probably has a grant on this for all I know already, but like compare video games with an equivalent amount of TV time, to actually compare the different modalities of screen time and do it in boys and girls, because it is strange that now in a couple of big samples we see that same association, and it would be interesting with something other than just as simple as the boys are in front of the video games more than girls.
Yeah, I do agree base rates are, boys spend 1.1 hours and girls 0.6 in terms of computers, so
Yeah.
that probably is contributing, so I agree there. So moving on to your intervention study. So did you, part of the exclusion criteria, so you instructed subjects to abstain from exercise 12 hours in advance, right? So roughly 7 p.m. the night before. So did you measure, how did you measure how much they ate the day before and how much they exercised the day before? Did you measure?
So we did, and we took them on their word, mainly because we were already measured physical activity at baseline for a week. And then we had measured it after they left the lab. So we were already doing a lot of accelerometry, and just in terms of having enough accelerometers to do the study once, we didn't have enough to send out that many and initialize them, and parents would have had to come in an extra time. So logistically, it would have been ideal, but we weren't able to. And the same thing with food intake. It's plausible that if they had a crazy high fat the night before, they could have an impact. But again, yeah, this study was really pretty burdensome on the families. They had to come in 4 separate times. You know, a lot of them lived outside of town, they had other kids, the whole family was coming in for 7 a.m. on 4 separate occasions, fasted. So I'm very skeptical that if we had told them, your family has to eat an identical meal night for every study, that they would have done it.
Yeah.
And also a lot of our kids were very active, you know, like they were on soccer teams and competitive hockey teams and gymnasts. So if we had, you know, tried to rule out all physical activity the day before instead of just 12 hours before, I think they would have either just lied to us or balked at the study. So we just, so we controlled as much as we could, and we just weren't able to control that.
Yeah, I agree. There's that balance between control and logistics and compliance and but we acknowledge that. Let's say if one kid had a soccer tournament the day before and expended way more calories than the same level, that could potentially impact the feeding. So here's something a little bit more controversial. So your overall conclusion with the intervention study, quote, breaks in sedentary behavior with or without structured exercise has no measurable impact on cardiometabolic risk. Period. Okay, so as you analyzed it, which was gold standard, makes effects models over time, textbook, according to p-values, and from that sense, I agree. But that's not the only way to look at impacts of interventions, and especially with small sample sizes. Are you aware of other methods that can sort of look at between differences that really don't use p-values that can possibly alter that conclusion?
So like looking at sort of like effect sizes and that sort of thing? Yeah, and so I looked at this a little bit, and it was, because I mean, nobody wanted an exciting, sexy finding more than me. So you know, so we, like I did our analysis and wanted to make sure that this was a consistent result. And it seemed like, you know, it wasn't just this is the way that I decided to do it and have to get this result. This was a consistent finding that no matter how you looked at it, and no matter what risk factor you looked at, there wasn't even a consistent trend. You know, it wasn't like the day with breaks and structured PA was the best across the board, just not significantly. It was only even the best day, like not significantly the best, but different on for insulin. For the other risk factors, it wasn't even the best of the three. And so yeah, whether you looked at it, you know, with actual p-values or sort of more flexible, holistic look at the data, it wasn't showing anything.
I'm not sure I agree. I looked at the data last night, and actually, looking at, so if you want to go to page 100, the table is 5.2. Now I know those are means probably averaged across the day, but according to my calculations, the effect size for insulin, which was your, I think your
Yeah, that was primary.
it wasn't like for the breaks plus physical activity group.
Yeah.
They had less insulin, the sedentary group, and the effect size was roughly 0.3 to 0.4, which is pretty
It's
good
not
size.
bad.
You're not going to find it with one subject, but you could find it with 4. You know,
Yeah.
45. And then for triglycerides, it was a point in the expected direction of 0.5. The effect size was 0.5, with a p-value of 0.1.
But then
So in the hypothesized direction, so I'm thinking, because in your sort of conclusions about this, you defend the sample size, you defend the calculation, and you're basically saying it's absolutely not a power issue, which you're reiterating now. I'm saying, actually, I think, you know, it could very well be a power issue, and if this was my data and I was applying for a grant, and this was like a pilot study, and I'm showing effect size of 0.3, 0.4, like I would find that actually kind of encouraging.
I guess, yeah, and yeah, your point is well taken. It is encouraging. I don't think if I tried to take the opposite approach and say we're really seeing something here, I think I would feel very uncomfortable doing that. So you're right. I still find it strange, you know, that we see something with insulin, but then with glucose that, you know, it seems to not be going. And so that's the thing that's
So there's no consistent pattern, but with triglycerides,
a little bit, which would be the two you'd expect the most are insulin and triglycerides. So you're right. It doesn't completely rule it out. No, you're right.
Yeah. Well, I just you know, from a strict textbook scientific point of view, I think your conclusion is solid. And just from a conceptual point of view, thinking, I don't know if you're thinking about like, you know, there's no point in doing another follow-up intervention. This doesn't work, whatever. My point is, I think it might have been, you know, a little underpowered.
Yes. Well, and that's something especially we talked about, you know, JP and Mark and I, and even throughout the study we talked about, you know, possibly looking at other populations. So looking at kids where we might see something a bit different, using, you know, like I talked about with Susan, using a bigger test meal. And there are certainly ways, now that we've done this one, seen no change in this group of kids with this design, and there are quite a few ways we could do the next study to see if that's consistent if we tweak things a bit. And so I'm certainly not throwing in the towel by any means. I'm looking at the sort of intervention in kids by any means.
Good. Do I have time for one more?
Yeah, sure.
Yeah, okay. So I think insulin responses to meals can vary even within individuals based on perhaps stress levels or sleep or just some day-to-day variations. What do you think, what do you think results would look like if you didn't actually feed them? And I know that you have an ethics issue, but from for like, let's say 4 or 5 hours or 6 hours, so they're just on bed. So then you're really isolating the true effects of sedentary behavior and eliminating that sort of variability due to meal response. Would you be more likely, I think, to show effects of interrupted like breaks versus
On metabolic markers or
on
on
metabolic.
And so they would, after the 5 hours, would they still be fasted, or at that point we do a meal challenge?
Totally fasted.
So I don't know, because most of the things I've looked at are in response to a meal challenge. And so the fasting values, especially if you start fasting too long, then things can change as well.
Yeah.
Yeah, so I think one thing that would be interesting, and this is sort of what they've done more in David Dunson's group, is they sit for a couple hours, then they have one test meal, and then they follow for 5 hours. And I think Dr. Sisson's study in kids was sort of similar to that. And I think if we were to do it again, I would go with that approach. The reason we didn't with this was because we also wanted to look at the food outcomes and the physical activity, and so because of that, we were limited in how we could do it, because obviously if we're giving them a high-fat, high-sugar milk take at noon, and then a buffet at 6 or something, that's going to really be a weird day for that buffet. So in that situation, I think then we might see something more interesting. I think that's the approach I would take in the future, for sure.
Okay, good, thanks.
Thank you, Dr. Kenny.
Thank you. That's number 4. So anyways, thanks a lot for giving me a long thesis to read that I read at the end of July. And I reread this week. Again, I think echo the comments from your other reviewers. I think did a great job. And I think doing this kind of work ultimately is very challenging, and I think the presentation that you put together in your thesis is very strong. And you and I have had discussions in my PhD course about this whole concept of movement variability, about people being sedentary and then increasing the levels of physical activity. I'm more interested at this stage in really trying to understand the physiology behind all this. And when I look at the slide that you presented, where you showed you had 65 minutes of exercise, 8 hours of sedentary behavior, and you had the 1 versus 5, and you had screen time there. And if I'm looking at that, and I'm thinking of all the messages that we've learned over time, we think, well, geez, if I'm exercising for 65 minutes, I should be fine.
Right, your goal.
So, explain to me the physiology. Why is this 1 versus 5 a factor? What's affecting the physiology behind it? Because I'm trying to get my head around it and try and understand it.
So there are a couple of things, and I should point out, so most of the mechanistic evidence comes from a couple studies from Mark Hamilton's lab in animal models. And they're very plausible, but people are just now starting to look at biopsies in humans. But it seems as though, based on Mark Hamilton's work, that when you sit for a prolonged period of time, basically your lipoprotein lipase activity drops. And so that, of course, can result in increased triglyceride levels in the blood, reduced HDL cholesterol. And what's interesting is that exercise also can boost lipoprotein lipase activity. But they found in animals, so either exercise or just letting them start standing again boosted it. But the interesting thing is that it's very, as I mentioned to Pascal, it's in different muscles. So it's more in your fast twitch muscles are the ones that see the big boost following exercise. And it's more the oxidative muscles where you see it following the resumption of standing. And you know, the differences in the genes involved as well. So it does seem like they're parallel but separate. And so I think that's, at least in adults with sitting. But with kids, when it comes to screen time specifically, it seems as though it's more so than the physiological response to the sitting. It seems to be something about the screens that's associated with food intake. It's, you know, among the most consistent associations with obesity or excess weight gain over time is with food intake. With TV viewing. And intervention studies like the one JP's done, there have been a couple others in the States where you expose kids to TV, they consistently eat more. When you force kids to cut their TV time in half, they consistently lose weight. So we touched on that in our systematic review of the Canadian Sedentary Behaviour Guidelines. So it's, I think with screen time specifically, the problem is at least as much the food intake that's associated with the screen time, and it's probably more so. And then the screen time might also, you know, have impacts on sleep and things like that as well that could also impact weight gain and metabolic risk. So it's not necessarily the physiological mechanisms that you'd expect at the beginning, or the ones that I expect.
Because I think, you know, I mean, screen time for me is a real, I think it stresses me out, especially when it's grant writing time. You're
Yes,
sitting
of
on the
course.
screen, right?
Yeah.
So, I guess my biggest thing in terms of the physiology is we need to be careful in terms of really relating the consequences of screen time versus the underlying physiological mechanisms related to, you know, equal amounts of physical activity, because the 1 in 5 factors that underlying the changes that you're talking about are more perhaps a factor of the activity associated with the screen time or the exposure to screen time, not necessarily, maybe it's behavioral, and less so the physiology. Because the reason I'm getting onto this, and I want to talk about this a bit more, is because ultimately it's what is the message that we're going to, what is the message that you're going to leave people with?
Yeah.
I mean, if we go back and we say, okay, if you do 65 minutes of physical activity, but yet by the nature of you're a very hardworking student, you're in front of the computer that much, and you're going to suffer. So do less work in front of the computer, or do less homework, because you're going to be sitting there anyways. You're going to be doing your homework. So what message are you really sending out there if you put this kind of information out there? I'm trying to line up my head here, physiology with what's the underlying changes.
So I think a lot of the time when we talk about kids, so the study, we looked at leisure time, screen time. And often that's an important distinction to make, because obviously kids need to do homework. And so I think it's important to focus on the leisure time activity. So that's a big one. And I will point out, it's not as though physical activity doesn't matter. The way I sort of think of it in my head is that conceptually it's sort of like smoking. I mean, if you exercise an hour and a half a day, but you smoke a pack a day, it's still bad for you to smoke. The exercise is still good. And so I think, the exercise is still awesome. If you're doing that 65 minutes a day, you're going to be a healthy kid. But it'd still be ideal not to watch so much TV. And so I think that's sort of the message. I guess it's not really, I'm not sure if that's getting at the physiological underpinning of it, but I think that's still the message. I mean, we still need to promote physical activity full tilt, which is in addition to.
Right. Are there any other, beyond screen time, are there other factors that could lead to the same consequences?
So you mean like other behavioral factors that are?
Is it just screen time? Are there other?
Well, I mean, there are other forms of sedentary behavior, so things like reading, obviously, is sedentary behavior, which hasn't been. So, are you getting at like other types of sedentary behavior, or just broadly?
Yes. So if you put a list out there, if you're going to give a list,
Yeah.
and you're going to say, okay, here's what to watch, here's what you need to watch for,
Right.
or be cognizant of that it can have a detrimental effect on overall health.
Yeah, and so, I mean, again, if we're talking about sedentary behaviors generally, I think the Canadian Sedentary Behavior Guidelines do a good job of saying, limit screen time. Then also saying, you should limit prolonged time sitting generally, and they give examples of, time spent in cars is another big one. So time spent in front of screens, time spent in cars, in front of cars is also bad. So those are the two big ones for sedentary behavior. I guess otherwise, the emerging one, the big behavior, and I think it's all linked up, is sleep. Is a big one that the kids who sleep more tend to be healthier. And it seems like you're mentioning stress. If you don't sleep enough, your stress hormones go up. If you're in front of a screen, that could have some sort of stress response. I think Angela Tremblay did a case study, or someone did a case study of like weight gain during grant season, and it found people gain weight. And so or there was a letter to the editor or something on that. So I think sleep, screen time, and physical activity seem like the big hitters in kids. Yeah.
So if you were coming up with, because I guess I have to try and align your findings from your first two study versus your study, because they don't align very well, do they, right?
Yeah.
So at the end of the day, I'm trying to understand in terms of frequency, this whole idea of frequency, volume, intensity.
Yeah.
How does all fit into it? Because essentially what you see is in terms of, of all the years I've trained a lot of Olympic athletes, and I train all the time, and I train with the diabetics, the older diabetics, with Angela and Ron and Gary in our Hardy study. Essentially, one of the things we push for is intensity, because intensity, there are other physiological changes that occur that are fundamentally important. But what I'm having a hard time with is figuring out what is that threshold. From your results, I get it that yes, physical activity is important, but I think what gets diluted in here is the importance of the improvements associated with higher physical activity and the need to do it, because ultimately if I can work at a higher intensity over time, I improve my overall cardiovascular performance fitness, which leads me to work at a higher intensity and sustain higher loads, which ultimately have a greater effect. But if we mix that message, and this is just commentary and you can add, give me your perspective on this, and I've talked about this in the PhD course, is ultimately if we dilute that message and just minimize it and say, okay, just interspersing physical activity is enough. Is that a bad message to send, when in fact the bottom line is you have to do a certain amount of, you have to be real, you have to do a certain amount of physical activity to get a benefit. It's no different than if I'm trying to treat a disease with medication. You would tell somebody, like with diabetes, you need this dose every day. If you don't take it, you're not going to improve. So how do you align the two?
So I think, biggest bang for your buck is always going to be the heaviest exercise you can sustain. You know, like intensity is always something you want to go for in exercise. And so I think that message is still true. And the reason I didn't focus much on that in the thesis is just because that area is well covered, and so I focus on this sort of emerging area. And so the other thing, so I don't think we need to minimize that message. I think we still need to tell people, like I said, that get as much activity and as high an intensity as you can sustain. The thing that I think is very interesting with the screen time and sedentary behavior stuff is that it might be less efficacious, but it might be more effective. Especially if you have people who are overweight or obese, or people who have elevated risk at baseline. It would be great if they went and did a structured exercise program, but we know that they'll compensate for that and may not burn any more calories, may burn less after the program anyways. And we know that they may or may not enjoy it. So that's why I've been really impressed by these studies in kids where they cut their screen time in half. It is, considering the small changes we typically see in exercise interventions, it's surprising the consistency and the size and the duration of the changes, the body weight leads to screen time. So I think we need to still push the physical activity, but the other thing is that it might be sort of a gateway drug into physical activity. Somebody, the healthy lifestyle behaviors seem to cluster, right? So if we get them doing some, they're feeling better about those, then it might be easier to get them doing a bit more of the physical activity. So I know the public health message gets increasingly complicated when we have more and more things, but I think it's important that we focus on sedentary behavior and not just the physical activity in sort of moving forward.
Yeah, that's good. I think of it from the perspective of all of, for example, we've done a huge study on older adults looking at, obviously this was a thermal study, but essentially looking at firefighters as one cohort of subjects, some of the older firefighters, and it was amazing to see that these firefighters had, in their minds, because they were physically active, they're going out fighting fires, that they were extremely fit.
Right.
Ironically, when they came in and we did all the stress testing on them, some of them had VO2 maxes of 29, 31.
Oh.
And a lot of them do strength training, big bulky guys,
Yeah.
But essentially, it's the fact that, and I did a study or wrote a review on the fact that in many occupations, the intensity is not enough to offset some of the age-related changes in fitness. And similarly, the point I was making in regards to you is that ultimately the physiological benefits in terms of exercise are limited when you're just talking about interspersing with small activity levels, because there's also the benefits to prolonged physical activity, sustained, and as Denise showed, and I believe some certain groups that Laval showed, intensity of exercise, even doing, interval training is extremely important. So I think and that's why I'm asking about this, because in your thesis you don't get into sort of differentiating the importance of physical activity as you're talking about in terms of that term you use, movement variability.
Right.
Okay, and try and sort of give it a meaning, because ultimately it's the same message that you see with workers. They think, miners the same thing. If you go down there, they're always working, but it's amazing to see how out of shape they are, right?
Yeah.
But it doesn't make sense. They're working 8-hour shifts, and if you see on the video, they're drilling repeatedly for hours and hours. So
Yeah.
how do you align this? How can you then tell me, you keep saying, well, you be physical activity, but at the end of the day, the intensity, they're not getting sufficient enough stimulus. So that's why I was trying to align. When I read your thesis, I clearly understand the importance of promoting that. But at the same time, I wonder, we need to be careful about diluting the message at the end about the importance of, the idea of frequency, intensity, and volume of work.
And I think those are especially important when we talk about fitness specifically as an outcome. That's one where sedentary behavior. There have been a couple studies showing us with fitness, but I think that's the one that physical activity will always be way more important for fitness specifically, aerobic fitness.
Right.
And I don't think standing and taking frequent breaks will ever have much of an impact on that.
That's good. Thank you, sir. Good job.
Thank you. We have time for the second round of questions. Dr. Sisson, do you have any other questions? She's still there.
Yeah, this happens to be every time. Yes, again. Should somebody run over and grab the woman?
Yeah,
Yeah.
you want Pascal and see if,
Travis?
If you want, we can go around and ask our questions. Okay, well, if you wanna move again? Oh, there he is, yeah, so we can wait. Sorry about that.
We can hear
Can
you,
you
sound
hear
a little
us?
distant.
Okay, we were wondering if you have any other questions to ask?
My university's lost whatever it needed to be there, so I'm really sorry that I missed out some of your really good questions. I got specific, of your answers.
Lost the
But
visual.
Sorry about
I
that.
just wanna make sure if I need to ask questions again, or,
Yes, that's what we were wondering, if you have any other questions to ask at this point. We can't see you, but we can hear you.
okay, I think it's because I'm on the telephone, I don't think I'm on the web thing.
Oh, okay.
Okay,
I
please
had
go ahead.
further questions, but I wasn't sure the rest of the procedure, and I apologize for the technical difficulties.
No problem, this happens frequently here, so that's not a problem.
Yes.
Can you hear me now, or do you want us to
I
wait?
can hear you,
Okay,
yeah.
perfect.
I can hear you.
Okay, please go ahead and ask your questions, if you have any other questions.
I didn't really have any, major other questions outside of, Travis, what are your next steps for your science? You've obviously used a variety of methodologies and a variety of study designs to thank you for that kind of approach. And so what's, your next steps for your science, moving forward?
So, immediate next steps, I'm starting a postdoc in January working with Chris Blanchard at Dalhousie University. He has a really interesting data set. He has a whole bunch of accelerometer data from people with cardiovascular disease, type 2 diabetes, and cancer, and both within and both in and out of cardiac rehab programs. And so we know that sedentary behavior is associated with a lot of those chronic diseases, but there hasn't been much of a characterization of sedentary behavior in those populations, or how it's associated with risk in those populations. So I'm going to be working with him to characterize sedentary behavior and physical activity patterns in those populations, see how they change over time, and then hopefully start looking, because he has access to a lot of cardiac rehab programs, start seeing what are the benefits of adding a focus on sedentary behavior to cardiac rehab programs, to see if people are open to that, see if that's beneficial, see if it's efficacious or effective. And so that's sort of the immediate plan, and then I'm hoping to stay active in kids, because I know, based on this study, we're very interested in seeing what happens if we look at a different population or slightly different study design. So I'd really like to keep one foot in the pediatric world as well. And also I want to keep looking at movement variability to see if that holds up in other data sets, or if it was just, if we just happen to look in the one data set where it's important, or if it holds up in adults or other data sets.
Great, well, good luck with the postdoc, and looking at some of those other population groups, I think is really an important area. So good luck as you move forward.
Great, thank you.
That's all my questions.
Thanks.
Thank you. Thank you very much.
So I'll continue a bit on the first question that I was asking, and the reason why I was asking those first general questions, Travis, was related to energy expenditure related to this movement variability, is a bit in line with what Glen just raised at. Regarding study 3, actually, when I read the proposal, the design of the protocol, I was actually surprised to see that you were expecting, as this study that I haven't read, like in the adult population, that has looked at the effect of being sedentary for 7 hours versus having different bouts of exercise. The reason why I was asking if the variability that you're actually imposing in this protocol is translated into a significant energy expenditure was because I would like you to guide us about the regulation of blood glucose.
Okay.
So when you look at blood glucose, like physiologically speaking, this is a very precisely regulated variable. And as an athlete, I'm sure you've had, at some moment in your career, athletic career, like you had some moments where you had like a lack of
I got some
energy.
granola bars here,
But, for the benefit of the audience, could you remind us, how long it takes for the blood glycemias to decrease when you're exercising at a very moderate, like let's say moderate high intensity, like 60-70% of your VO2 max?
So to come back, so after you had the brief like hyperglycemia and then come back to normal, that's what you're asking? So I was reviewing this week, and so one thing, because we actually, when I was at Queens, we used to teach labs on this. And this is one of those things that I find in textbooks, it sounds like this thing that's really perfect. It's like the plateau and VO2 max. And then I found when we would run labs trying to show this to undergrads, it was like 1 in 5 where we actually saw it. And some of the research I've seen, it seems like it's much bigger in folks with diabetes, and some of the stuff I've seen from like I think Michael Riddell from New York. It seems like it's a bigger spike and a longer spike in people with diabetes. So
But if
yeah,
we
we
stick
sit
with
with
the normal
healthy people.
population,
I'm honestly not sure. I'm going to say it's on the order of 1 or 2 hours, but I'm honestly not sure more precise than that.
That's a correct answer. So it's going to take like 2 hours if
Yeah.
you don't feed yourself during the marathon. So you start having a very finite decrease in blood glycemia.
Yeah.
So based on your hypothesis of study number 3 and 4, actually, I was wondering, like, were you, like, personally, I was not surprised about the result. Like,
Right.
compared to Gary, who's trying to say, well, there's something there, like, physiologically speaking, I'm totally not surprised about the results, because the energy demand of the variety of movement that
Yeah.
you're using is so negligible in terms of energy demand that the blood glycemia will just remain, like, perfectly stable. So
this
were
is
you
and
surprised about the results?
well, and it's not in terms of, because it's always in the, it seems like it matters much more in the postprandial state. And so that's where I think the sedentary behavior studies are so interesting, because of the David Dunstan study, it was almost an identical design, except instead of having the big bouts of physical activity, they had either bouts of 30% of max or 60% of max, I think.
Which is more than what you've done.
So they compared the two intensities. Yeah, so one condition was just light, one was just moderate.
Right.
And what they found actually, the insulin and glucose reduction, like the area under the curve, was the same whether it was light intensity or moderate, which again is not what you'd expect. And there have been a number of studies that, again, based on what you'd expect as an exercise physiologist, it's surprising how a day of sitting versus a day of standing or walking can result in substantial differences in insulin sensitivity. And so that's a systematic review that we did that wasn't included in my thesis, but largely informed it, was that there have been 3 or 4 now studies in adults with just a single day of sitting, and found that, yes, on the order of 20% of insulin sensitivity or area under the curve, or depending on how you look at it. So that's why, again, I don't think it's necessarily due to energy expenditure. It's not. It's sort of a different paradigm, and it's weird when you're used to thinking of physical activity being the key. This doesn't make any sense. And unfortunately, they haven't done as many mechanistic studies looking at glucose transport proteins. We know that David Dunstan's lab just did, based on their study, they took biopsies from some people, and they found that the light breaks did upregulate a bunch of genes related to carbohydrate metabolism. And in people who are paralyzed, if you electrically stimulate their legs at an incredibly low intensity, you still get a big spike in GLUT4 translocation of the membrane. So I know they're a very specific case, but yeah, it's in adults more consistent than you'd think, and that's why we were surprised in kids, because it is pretty consistent in adults.
But do you agree with me that, like your design per se, like, when they were requested to remain sedentary, where this glucose that you had feed them, like this meal that you provided at lunch, breakfast and
Breakfast,
lunch,
yeah.
what's the organ that is mainly consuming that glucose?
Well, I'm assuming it's their muscle and their adipose tissue, the two big things
Muscle?
they're taking up.
Mainly? Or which is the major one?
I'm going to go out on a limb and say if you're sitting, there's probably going to be adipose tissue, but that's a bit of a shot. I mean, and I'm saying that because you're an adipocyte biologist.
No.
I know when you test some insulin sensitivity, like a clamp, it's looking at the muscle.
Yeah, the fact is a different story though, because you're priming
No, I know, yeah.
at a very high level, so then your muscles are coming to play. But when you're, like most of us now are probably in the postprandial phase,
Yeah.
because we had a nice breakfast to come to your show. So, like the major organs that are fueling now your glucose, guys, is your central nervous command and the fat. So that's why I was asking the energy expenditure related to your like movement and priority, because to me, like it's so negligible that I would not expect any difference in this. Of course, you haven't traced like the fate of glucose, but when you design this kind of study, that I find that sometimes you need to think about the mechanism behind this regulation of glucose. But you're right that being sedentary for a while is actually now, and it's emerging now that it's associated to some physiological mechanism that we're not aware of yet that will affect or modulate this regulation of glucose.
Yeah.
But that was more a comment than a question actually. So what could you do actually to, let's say, support your hypothesis? Say that you want to have, like, what could you have done?
So,
Like,
so
to
to,
basically, like, trick the show a bit to, demonstrate that high variety of movement would induce a better clearance or consumption of glucose.
well, so I think, and this is something that we've talked about internally a lot,
Right.
that, so you mean how can we have better differentiated sedentary versus, so I think the big one that I sort of mentioned earlier to Susan is we had a bigger challenge in that meal. If we had higher sugar and fat levels, I think it would have been,
Do you think so? Because the meal, the breakfast, from what I remember, the breakfast was composed of how many grams of glucose? 60?
for carbs. So it was, there was a lot of it was in, I was gonna say Whole Foods, but it was in bread and peanut butter and grapes. So it was, and there was a glass of juice. So I mean, it was relatively high in sugar, but it wasn't exclusively sugar.
Because to me, the challenge, like, in terms of the carbohydrate levels, was totally sufficient. Like,
Yeah.
even with your breakfast, like 60 grams will take 6 to 7 hours to be consumed if
Yeah.
you're sitting to bed. Because you're consuming now, what, how many milligrams of glucose right now?
Rest?
At rest, yeah.
Oh, milligram, like,
Or gram, or kilocal, whatever
Oh.
units you want.
for kilo, I mean, I'm gonna assume I'm around 1 minute. So I mean, around 3 milliliters per kilogram per minute of oxygen. I'm probably, well, because I'm stressed, I'm probably more like 2.
So what's the contribution of carbs is it?
The contribution of carbs to that, well, it depends because I'm not as fit as I used to be, so I don't know how that's going to play into this. But I'm going to say the contribution of carbs would be relatively low at rest. I mean, it's using a lot of fat and will be fat at rest.
So at rest, you're basically using 150 milligram per minute of carbs. So to go through your
It
breakfast,
takes quite a bit.
it takes how many hours? A lot of hours, like being sedentary. So I think your challenge was, okay, so what
Yeah.
else could you have played with to modulate this curve of glucose as
Yeah.
you were expecting to have?
Well, so another one that I didn't really talk about in the thesis, one as possible is most studies, I think Susan mentioned this in one of her comments, most studies have actually looked at the bout before the meal. So you would have a day of sedentary, a day of whatever, and then you'd have an ODTT the next day, which I don't know physiologically why that would be any different, but I think it would be interesting to test that. Another big one, and this is one I know JP would really like to do, is look at kids who are insulin resistant or glucose tolerant at baseline, where any given load is going to be more challenging for them. So I think that would be
That was
interesting.
my other question, because you're working with healthy kids, and
Yeah.
for them, like giving them like, a big spaghetti plate in the morning or 2 or 3, it's not gonna change because they can deal with that. But I think the challenge would be more, or what we're trying to test, I think would be more perceptible in people that have some problems with breathing.
Yeah. No, and I agree.
But
And
that's personal, I don't have any
No, I-
supporting evidence for this, but physiologically speaking,
I think
based
you're
on
right.
the energy consumption of your design, I would not expect any difference, and I'm glad actually that you don't, because I'm gonna show that
I
in my
don't-
class.
Yeah, it's reassuring.
Saying, even if you start moving a bit, like glucose regulation is so well precise that, it should not be a problem.
But you should also show them all the studies in young adults too.
Yeah, I'll actually study that,
Yeah.
and I'm gonna digest this article,
Yeah.
I wonder why you've seen this difference, I'm totally.
Yeah, no, I think you'll enjoy it. And I agree, and that's the thing with this study, we debated a lot about the population. Should we take
Yeah.
all comers, should we focus on kids? And there are a lot of difficulties recruiting and maintaining kids who have elevated cardiometabolic risk. So we thought for this first study, it makes sense to focus on just kids. But no, I think if we do this again, it would definitely make sense. And I think it's more plausible that you see something there. So I think that makes a lot of sense.
I'm up, thank you. No, maybe like an open, like, are we finishing after this?
Well, after
Yes,
the
because,
second
you know,
one,
it's a
Dr.
good-
Tremblay has
Yeah,
probably
last question, this is totally general, Travis, so tomorrow you will be hired by the Prime Minister of Health of Ontario, so what's your plan to try to resolve this kids sedentariness problem? So you're his right arm and you have
Yeah.
not limited budget, so you can do whatever you want, so what's your plan?
And I bring my wife because she's a teacher, so she has a lot more day-to-day interaction with the kids.
That's good, and you can work with her.
Yeah,
Sharing the bed and the bench is always good.
Yeah. So I don't know. I mean, it's tough. I mean, you know, our lives are really built around sitting. You know, like it's, if you're standing at a meeting like this, you're often seen as being aggressive or confrontational. You know, like we have way more chairs than we ever need in any given room. And Mark Hamilton from the States makes the point that sort of like in the South, you know, you used to have spittoons everywhere because just people were, you know, chew and dip. And we've gotten away from that as a society, but we're still expecting people to sit. So I think you know, there are a lot of little things like, you know, promoting active transportation for kids. They're not sitting the whole way to school, so they are walking some or biking. I think it's, you know, looking to see if we can have standing more in schools, which I know there have been some pilot studies, and kids and teachers seem to tolerate it, and it does really reduce the time sitting. I think screen time's a tougher one because it's so much under parents' control. I mean, a lot of the impacts of screen time, TV specifically, seem to be related to food ads. And if you watch kids' TV, there's a lot of food ads. And I remember when I was a kid, like being sick at home, and it was just constantly food ads. I remember complaining to mom, she would never let me go get the food. So I think, I know Quebec technically bans advertising to kids, but it's a technical thing and it's unenforced. Coke doesn't advertise for kids, but they have video games for kids. And so I mean, if we could somehow limit advertising for kids, I think that would really curtail a lot of the negative impacts of screen time, or somewhat with respect to energy intake, but I don't know how you do that. So unfortunately, there's no like silver bullet.
The Prime Minister is calling you.
And so
What
this
do we do about that?
Yeah, and so there is no silver bullet. I think we have to continue to get the message out that screen time and sitting are bad, independent of these other risk factors, to try and get people aware of it. And the awareness is definitely much better than it was 3-4 years ago when I started my PhD.
Because I thought today that, you know, we would come to this Thesis Defense,
Yeah.
and for the first time in my life, we would stand up, because you're very innovative,
Right.
and I actually challenge all the kinetics students that we should do that at some point. I'm starting teaching, and I'm asking the kids to, like, kids, university people, to stand up, and, you know, this is to confirm what you're saying. We should start just changing the minors.
We should.
Details to,
No, absolutely.
prime up the engine.
No, we absolutely should, and it's just converting that to a public health scale. It's not like smoking where it's easy to say you can't smoke within 9 meters of the entrance.
That's a tough one. I don't have answers for
Yeah.
that, and I'm just learning, testing your circulation.
Yeah, I know. I think it would be great if we could do it, and I mean, as a kid, I watched a lot of TV, so I'm not a good example, and I don't, and with things like Google Glass scares the crap out of me, you know, like the screens you can wear all the time. Like, we know screens are bad, and every year there's a different type of screen, and they're becoming more ubiquitous, and you can wear them all the time. So I don't, like, so I don't have a good answer because it's just going to get worse. You know, really, if it continues in this trend. Yeah.
Good, thank you. That's all.
Thank you, Dr. Goldfield.
Okay, so just to sort of piggyback a little bit of what Pascal was saying. So, and also Glen sort of alluded to this. Like, so, you know, we ran a nice acute laboratory study. A lot of clinicians, people in my backgrounds, favor RCTs. You know, they might say, some cynics might say, like, well, you know, what's the point of the lab study? And even if you did find effects on glucose, and, you know, maybe they would have, you know, if they worked out hard and intensely, at the end of the day, maybe everything would normalize. So,
Right.
like, so, you know, what really, like, what if someone cynical would say, like, what's really the value of this?
Yeah. So I think that's a very reasonable response, I think. I think Eric mentioned that to me a few times during the study. And so I think that's a very reasonable response. And I think this is the first step to see, is there acute impact of sitting, period? Then you start to do, okay, if you sit all day but you exercise, is that better off? So I'll come back to that in a second, but I think, so the reason why you would think, you know, if your insulin glucose response to every meal or your triglyceride response to a meal is higher, it's, you know, I've heard the term micro insults. You know, if every day your insulin levels are spiking way more than necessary at every meal, your glucose levels are spiking at every meal, then over time that's going to have a negative impact on your health. So that's why, even though it's an acute impact, why it could still be an important thing to measure. So that's why that's important. And I think that's where the meal, it was good that it was an ecologically valid meal, because then if we had seen something, it would be, you know, not when we give you a milkshake that your kids are not consuming, but a meal that could be had for breakfast every day. Then in adults, actually, they've actually started to look at now, okay, what happens if you have a day of sitting, a day of standing, or a day of sitting plus a bout of vigorous exercise? And for insulin area under the curve at a test meal, they actually found that the exercise is good, but the standing all day is better. There's one study in PLOS One. I've got the slides in my action. There's only one study, and it was 4 days of sitting all day, 4 days of sitting, 4 days of standing all day, and 4 days of sitting with the exercise. And so that's a fascinating study, I think. And so that's sort of the next step. Once we see if sitting is acutely bad for kids in any area, then I think you move on to that. Yeah. Does that answer your
Yeah,
question?
sounds logical. Good answer. This just might be a little bit out of flow, but so I want to get back to one of your conclusions, but just you acknowledge in the big studies, the first couple studies, the Ames and the quality cohort studies. So you acknowledge the cross-sectional design, the lack of causal inferences, but the tone of the thesis and the fact rationale for the intervention is a belief that sedentary behavior increases cardiometabolic risk. But are you like? I'm aware of some research, especially in animal research. I think Bob Lustig came and gave us a presentation, and I think he showed that rats that ate a diet high in carbohydrates, especially fructose, led to metabolic syndrome, and he believed that actually the metabolic syndrome and the fructose was actually negatively impacted, like making them more lethargic, making them more sedentary. So, like we're talking about this is like sort of one way, but isn't it possible that these increased cardiometabolic risk factors could also be negatively impacting sedentary behavior and physical activity?
I think it's certainly plausible. I think for some, it depends on which one. And the whole, insulin hypothesis isn't something that people universally subscribe to, but I think it's interesting. It has a lot of things about it that are very attractive, I think. And so when he gave that talk, I remember my response mentally was that, well, it'd be really cool, because I guess his main treatment is he basically tells kids, okay, go home, cut all liquid sugar out of your diet, especially fructose, but all liquid sugar, and then come back in 6 months and see if you're still insulin resistant. And then if they come back with still insulin resistant, he says, you haven't really cut out the sugar, go home, do it here. And he said, because then you're no longer lethargic, you're getting more physical activity, you're not having these big insulin spikes, it's overall, it just sort of fixes everything spontaneously. And so one of my initial ideas for a thesis project was, man, wouldn't that be cool to actually measure physical activity levels. And I still think that would be a cool study it's sort of his anecdotal evidence as a clinician that the kids are more active, because now they have more energy, but I don't know that anyone's actually tested that. So I think that would be very cool to do, and I don't think anyone's actually shown that. It is plausible, at least for some types of or for some specific risk factors, but I don't know that it's necessarily driving everything. And when we looked at, for example, in the quality cohort, we didn't include energy intake as a covariate because it wasn't associated with any outcomes in that data set. So that's why we didn't include it there. Yeah.
Did you like the carbohydrate intake? Was that like specifically?
No, we didn't, and I'm not even sure if they have that in the quality cohort or if it's so no, I'm not sure about that one.
Good. So one of your main overall conclusions toward back at the end of that thesis was that the findings suggest acute sedentary behavior may contribute or predispose a positive energy balance due to low energy expenditure and by failing to produce a compensatory reduction in EI and an increase in EP. So I guess I was giving that a bit more thought, and it seems like your results show that sedentary behavior intervention didn't elicit any compensatory reductions, median behavior, or increases in spontaneous. So wouldn't that, like if they did compensate in the sedentary group, if they did compensate any less, they would probably lose me. That's clearly not the case. So I'm trying to follow the logic. Like I'm wondering if there's a bit of a leap of faith. Like, couldn't you make the argument that because there were no changes across conditions in EI that maybe they would remain in energy balance? Sort of a little bit I think of what Pascal was saying. That there's not these major cardiometabolic changes or changes in food intake. So there's no compensation. So would that maintain energy balance, or like why would that predispose?
So you're right. So it would depend on what their energy balance was to start with. So I guess it could predispose to either, I guess, depending on how you look at it. That's true. And so either then, in that case, if you were thinking that not compensating would mean you would remain a stable body weight after a day of sitting, it would mean that then the exercise would lead to weight loss over time. or less weight gain as a result. So I guess, yeah, you could look at it either way. Over time, weight typically tends to go up as opposed to go down. So I think that's the more likely scenario. But I agree, you could absolutely look at it that way. Yeah.
And last question, so it's kind of getting at what Pascal said. I wasn't going to frame it in terms of Prime Minister hiring you, but more practically, you're a certified exercise physiologist, and so you're working with kids, and you can only pick one. You'd obviously work through there's many strategies.
Right.
You can only pick one guideline, public health guideline to follow, or one clinical guideline, to mention. And so would you advocate reducing sedentary behavior or the 1 hour of MBPA and why?
Okay. I feel like my answer is going to get slammed by Glen in a moment, but investigate more then. I would say screen time, not just sedentary time, but screen time specifically. And the reason, so there are a couple of reasons. One is that, as I mentioned, in our systematic review, which looked mainly at screen time in our meta-analysis, screen time, it's remarkable how consistently it's associated with weight gain, and how consistently when you cut down screen time, it cuts down body weight up to 2 years. In one of Epstein's studies, at 26 months, the intervention group was still significantly leaner and kept their weight off compared to the control group, and effects that you don't typically see with exercise interventions. So I think there's a benefit there for screen time. The other thing is that I think for obesity, and then by extension by a lot of the risk factors that tend to associate with obesity. And then the other thing is, again, when it comes to sort of effectiveness in terms of kids' openness to it, I think it's easier to buy one of these restrictive devices that simply limits the amount of time the TV's on than it is to necessarily get your kid active. Because you can enroll a kid in a sport, they might not get much activity time, depending on the sport, depending on the level. And the other thing is that, especially in the kids who you're trying to get physically active, kids who have elevated body weight or metabolic risk, it's really hard to get them to keep their physical activity levels up. And even if they do exercise, they often compensate or reduce their spontaneous physical activity otherwise. And screen time, you don't see that sort of compensatory behavior. The downstream effects of reducing screen time are probably positive. It's probably something like getting more sleep. So I think that's where if it was a world where people would actually do the recommendations, I'd probably go with physical activity. But in a real world, most bang for our buck, we want the thing that's going to improve the health the most. I think if everyone cut their screen time, it's easier and would have a bigger overall impact.
I agree. And I think your point that you mentioned before as a possible gateway, just reducing sedentary behavior and screen time may get them moving or doing it. They might replace it with reading or music, but they also might get them moving and light activity, which could then, like a stage approach, could get.
It's certainly not going to hurt their physical activity levels, guys.
Yeah.
Their screen time. Yeah. That makes sense.
Thank you. Dr. Kennedy, do you have any other questions?
Sure. Yeah, I do.
Thanks for I'm not going to get into that too much. Pascal brought it up, and I certainly wouldn't be standing. I'm not in agreement that, for example, that I would recommend that standing be performed in school. I look at it from the perspective of, I come back down, I come back again to intensity. What would be in your mind the benefit of standing all day in school?
So again, in kids, it's based on this. I'm not so sure the benefit, or at least the acute benefit of kids. It more stems from adult studies, and that's why I'm
Yes.
I
want you to look at it from. I want you to look at it from the neuromuscular fatigue. I want you to look at it from the just from the muscular fatigue effect, and the consequences that ultimately has on level of intensity of physical activity that somebody can pursue after. If you're standing up for
so
a long
you're too
time,
tired from standing, so you're not going to exercise.
I don't see. I want you to try and prove to me that there's a benefit.
So I'd say that the first thing is that I'd say it's not about standing all the time. It's about having the opportunity to stand. And so, like when I talk to my wife who teaches little kids at fidgety, some of them it's better if they can get up and move for classroom management and that sort of thing. And so they're burning more calories, but that's not that's sort of a side benefit in my opinion. I'm not sure because when you look at objectively measured sedentary time, physical activity, depending on the data set, they're not always really strongly related. The sedentary time is associated with light intensity activity, not with the moderate vigorous stuff. And so I think, just from my own anecdotal experience working at home, when I sit all day, like during my comps, I was exhausted every night, and I was sitting for like 14 hours a day. Whereas when I work at home, I have a bike/standing desk, and I do find if I stand for a couple hours, sit for a couple hours, stand for a couple hours, I do feel better at the end of the day than I do when I'm just, they call it email app, kind of hunched over, and like it's. So
So could you go out for do a 60-minute run at the end of the day to get your daily dose?
Oh, yeah.
High intensity, no problem.
Oh yeah, no, like my physical activity levels have waned throughout my PhD, but that hasn't had anything to do with my standing.
So then why go back to this? Because again, the messaging has not just been for children, but it's also been for adults and understanding. So why then is industry mechanizing to try and reduce the fatigue level associated with performing tasks that are 8 to 10 hours where workers are continuously standing? The biggest problem that they face is the challenges of standing up for so long, the fatigue associated with that, and ultimately not being productive. So I'm just trying to line all these things, and again, I want to be careful because there are studies on, even hemodynamic responses to prolonged standing. You see it even with military guys, it's a problem. So I just, I'm looking at it from, the fatigue and being able to perform after.
Yeah, and so again,
And do the types of activities.
So again, I think it's different. Like I know, dentists, physiotherapists, people who are standing cashiers. Obviously, there's you can get varicose veins. It's not good. It's bad for your back. But it's not good to be standing all the time either. And so I'm not advocating that.
Does that go back to the energy expenditure you're talking about? I mean, you're not getting a huge difference in there in terms of energy expenditure standing up.
No, you're not.
So I'm trying to align that with the health benefits that you really get out of it.
So again, it's tough because in kids we're still trying to see if there is an acute effect. But again, just based on adults, it doesn't seem like it's like in the Dudson study. The insulin changes, the glucose changes weren't different when they had high intensity or moderate intensity versus low. So it doesn't seem like it's like the energy expenditure is driving it. And that's why it's so sort of counterintuitive, the sedentary stuff, because we're trained to think about energy expenditure, and it doesn't seem like that's the main driver here. And
So how would we change in 200 years then, if in the wintertime in Canada, let's just say it's 1770, and you're stuck in your cabin in the middle of winter? I mean, you don't have a screen, but you're sitting by the fire, it's a screen. I mean, you're not doing a heck of a lot of work back then, so what?
Making babies.
So I'm just wondering what's changed, what's evolved?
Pascal's really.
If sedentary behavior like that occurred back then, let's just say it did.
Yeah, well, I mean, and that's where it's so hard to tell, like, has it gone up or down? And I think you can make a plausible case that for certain people at certain times of the year, yes, it's probably the same. But if you look at society as a whole, I mean, now compared to 100 years ago, more people are sitting down on their way to and from work. I'm assuming more people are sitting at work. I mean, we've moved from agrarian to office-based economy, so more people are sitting during the workday. There are more professionals doing sedentary work. So of course there are always going to be people that don't follow those trends. But I think it makes sense that generally speaking, you would spend more time sitting now than say 200 years ago. And even the people that and again, not all sitting is bad. It's still sitting and low energy expenditure. So if you look at the Voyageurs or something, we're sitting in a canoe, but still they're not necessarily sedentary. And I should point out the reason that energy expenditure is in the sedentary definition, it's sort of always been in there, and it used to just be based on energy expenditure. And then in the past couple of years, Sedentary Behavior Research Network put out a new definition for sedentary behavior, moving more towards the postural aspect, because it seems like it has to do more with engaging those muscles, the muscles in your back, muscles in your legs, might be as important, or probably more important than the energy expenditure aspect. So that's why it's now those two characteristics rather than just low energy expenditure sedentary.
I guess maybe it's just in terms of standing, it's nice, but you get the same effect. I remember, in grade school, we were always taught to sit up straight. Sitting up straight was a pain because you had to control your muscles, right?
Yeah.
I mean, I don't know if maybe they stopped.
No,
doing that.
really,
I just don't see that. Anyways, again, it comes back down to what I see as your major conclusion at the end of your page, thesis on page 136, where your very last sentence, essentially you say, collectively these findings suggest optimal levels of cardiometabolic disease risk are most likely to be seen in children who limit their time engaging in screen-based sedentary behaviors, who frequently interrupt their sedentary time, and who have high levels of variability in their movement. You throw the word variability in there, and it to my mind is simply back to the basics. Frequency, intensity, and volume. I don't see the difference between variability and in terms of I think what's missing in here when I read this, because variability and frequency to me means the same thing. ultimately they mean the same thing. You're just saying interspersing activity between all of these, changing up from behavior, from sedentary behavior, right?
Well, not just sedentary, but even going from light to vigorous too. So any of those transitions.
It doesn't matter, that's frequency, but that's what I'm missing in the whole deal, is the lack of discussion as well, or lack of reference to intensity. Come back to the basic, give me a threshold, give me some guidance. Variability is meaningless. I can talk about heart rate variability, and if I don't give it a threshold, it's meaningless when I talk about disease or when I talk about physical activity.
Yeah.
So that's probably the biggest challenge I have in reading the thesis is it's very generalized, and you definitely want to come up with some, some ways of referencing it to other types of activities, frequency, intensity, so we really understand. Variability is kind of hard for me when I read that as a conclusion.
Well, and I think, so in the variability paper itself, we give some examples of the differences between the low and high variability and what would be required. So it'd be like 50 transitions from sedentary to light, or from light to active would move you up from one tertile to the next to get those.
But it's the same concept. Again, I come down to anaerobic elactic training. You got your time to peak power maintenance. All these are, again, the same ratios that you're talking about. So what I'm trying to get across is you're trying to create a new sort of, I guess, a new sort of perspective on how to present it. But I just want to come back and see, let's just say Scott Powers came out to you. You know Scott Powers, you're at ACSM? Okay. Anybody, Scott Powers, was a famous exercise physiologist, wrote, he has his own exercise physiology book. So let's just say he invites you.
Yeah.
He invites you to write a chapter on exercise prescriptions for health and fitness. Okay, and if he asks you to write that, how are you going to integrate this information into that chapter? Keeping in mind, he's more likely going to keep you to the generic terms. How would you fit that in there?
Yeah. Well, so I think what I would do then, and sort of like when I was summarizing my slide of the take-home message, is always in addition to what we're writing about physical activity. And so I think movement variability is, because it's not just physical activity too, it's also going from sedentariness to light activity, which has also sort of been ignored traditionally compared to MBPA. So I think it's a way of conceptualizing an overall good movement pattern. So you leave that term out and say that, in addition to having lots of MBPA, lots of BPA, you want to have breaks in your sedentary time. And if you have those three things together, you're going to have a high level of movement variability. And so that's what I try to get at that paper, that it may not have a physiological impact aside from those three, but if you only look at MBPA, you could still have a whole lot of sedentary time. I mean, in my whole undergrad, I was active for 90 minutes a day, and then I sat the next 14. And so you could still have very low movement variability, very few breaks in sedentary time, and still be active. So I think if you get the activity, get the intensity, and get the breaks, then you're by default going to have movement variability, and we know all those things individually are going to have a healthy movement pattern. But does that answer your question?
All right, I got nothing else other than to say great job.
Thank you, Dr. Tremblay. Do you have any comments, questions?
Yeah, I do. First, thanks to Travis for a great defense. Thanks to the examiners for great challenges. It's been hard sitting here, harder than most actually, because I come from an exercise physiology world too, and I think that's been the greatest barrier to progress in public health, actually, the exercise physiology world. We've messed up a lot of times with the exact thing that Glen is trying to defend, so sometime I should be invited to your class, Glen, and we can debate this, because there's hardly a comment you made that I agree with, biologically or behaviorally. Coming back to the basics is exactly what we shouldn't be doing in the context of what Travis is studying. We know the FIT formula. This has nothing to do with it. This is not even part of the same continuum. Different biological processes, instigated by different things. And by looking through an exercise physiology lens, even with glucose control, we've done a systematic review. Every single study shows, just with bed rest, massive changes in insulin sensitivity, glucose tolerance, and triglyceride levels. Has nothing to do with exercise. the models, the training, the studies, the journals that we read as exercise physiologists are the wrong ones. They're constraining us, and the more we can break that bubble, the better we're off going to be in terms of public health. And I take full responsibility. I've written the Canadian Physical Activity Guidelines. We've trained the Canadian population to think that if you do that 30-minute exercise at the end of the day, like the Homer Simpson slide that most people have seen me show. So Homer sits in the car, goes to work, sits all day at work, sits in the car coming home, sits watching TV with the family. Was it an active day? No. 30-minute jog, he exceeds any physical activity guideline in the world. Is he healthy? Is his cardiometabolic stuff in check? Absolutely not. The literature is clear on it. You won't find it in the exercise physiology journals. You'll find it in other things. So I had to say that. Travis didn't say that. This is his defense. So I want to focus on him and congratulate him for 4 great years with Halo. Halo has benefited by having you, I'm sure, more than you have benefited by being there. So thanks a lot. He came in as a CIHR scholar. When that scholarship ran out, he got a Canadian Diabetes Association scholarship. So he's been top shelf the whole way. In addition to the papers in his dissertation, all of which I think one maybe isn't in press or published, he's published more papers on this topic outside his dissertation that we've decided not to put in for various reasons, but his productivity has been great. He maintains his very active blog with Peter that is very popular. He's the inaugural commissioner of the Halo Hockey League, which may have been his greatest achievement and one of the most remembered by. He's the co-founder of the Sedentary Behaviour Research Network, which I would encourage the people on the right side of the table to visit and read some of the literature that's on there. So he's done a huge amount. In addition, he's a sought-after expert by the media to talk about sedentary behavior. Many, probably more media interviews than most professors get in a year. And so I think it's a testament to his work and his abilities. So on behalf of myself and Halo, Travis, it's been a pleasure having you, and I certainly hope to continue working with you as you go forward. So, no questions.
Not surprised. Thank you very much, everybody. May I ask everybody to please leave the room for a few minutes? I'll come and get you when we're ready. Unanimously recommended your thesis for the degree. So congratulations, Dr. So we basically need the thesis back to the candidate, and I have the papers, and I need to speak with the candidate for a few minutes. And I'll speak with you for a few minutes. But
At the same time? Or?
no, not the same time.
Okay.
Oh, okay, so you will oversee the corrections, of course, in this case, because it's vertical.
Number one.
Okay.
And so if any, are there any scribblies that you want to add?
So basically,
Did you write anything?
You guys do have a no. You're not going back. Nope. So what are you doing now?
right? I've got a couple of part-time jobs, but looking into trying to figure out a full-time gig. So far, they all
Where are you looking?
China campus.
Like, I mean, in terms of like jobs.
Oh, looking. I thought I said living. I was like, what? That's an odd change. I don't know. I was looking at potentially like doing even just something with a sports organization, whether it's like management or something like that.
Oh, okay, cool.
I like to see it like so if possible. It's kind of limited though, the amount, but yeah, just see how it goes. So I got an application like Canada. See how that goes.